Hi everyone, we're going to determine whether this series converges or diverges. So we're going to use the ratio test. Anytime you see these combinations here, it's always a good idea to use the ratio test. So we're going to take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. All right, so if our limit is less than 1, it's going to be convergent. If it's greater than 1, it is going to be divergent. So let's use substitution. This is going to equal the limit as n approaches infinity of n plus 1 factorial times n factorial times 5 to the power of n plus 1, all divided by, and this is going to be 2n plus 3 factorial. All right, then we're dividing by a sub n, which is the same as multiplying by the reciprocal. So this is going to be 2n plus 1 factorial divided by n factorial times n minus 1 factorial times 5 to the power of n. Now, let's group everything together. So we got a lot of things going on here. So let's group our n's together and everything else. So let's group n plus 1 factorial divided by n factorial. And then we're going to have times n factorial divided by n minus 1 factorial. Then we have 5 to the power of n plus 1 divided by 5 to the power of n times 2n plus 1 factorial divided by 2n plus 3 factorial. All right, from here we're going to simplify things. We can look at certain things. I'm going to rewrite this a little bit, and then we're going to simplify. So we're going to write this as the limit as n approaches infinity of the absolute value of n minus or n plus 1 times n factorial divided by n factorial times n minus 1 factorial divided by n minus 1 factorial times 5 to the nth times 5 divided by 5 to the nth times 2n plus 1 factorial, and then we're going to expand our 2n plus 3, so this is 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. That's all absolute value. All right, now let's cancel things out. So that cancels out. These cancel out. This cancels out. And this cancels out. So what we're left with is the limit as n approaches infinity of n plus 1 times n times 5 divided by 2n plus 3 times 2n plus 2. All right, let's simplify our numerator. That's going to give us the limit as n approaches infinity of 5n squared plus 5n divided by 4n squared plus 10n plus 6. Now we're looking at our degrees are the same here. So we just look at our 5 divided by 4. So this equals 5 divided by 4. This satisfies condition 2. This equals our limit, which is greater than 1. That means it's divergent. So this diverges by the ratio test. Thank you. Have a nice day. Bye-bye.